Question number 10. Okay. So now, a lift consists of a passenger car supported by a cable that runs over a light frictionless pulley to a counterbalance. Okay, you have a lift over here, there's a counterbalance over here. The counterbalance falls as the passenger car rises. That means what? When the passenger car goes upwards like this will now come down like this. What is this called as? Attitude right? Okay. And then some masses are shown over here in the table, right? So what is the magnitude of the acceleration of the car when carrying just one passenger and when the pulley is free to rotate? You need to find out the acceleration. You had already done these kinds of problems when we were discussing about the free body diagrams. Anyway, let us do this, arrive at the free body diagrams. So this is my tension here, this is my tension here. Now this is the acceleration with which the passenger car is going upwards. This is the acceleration with which the counterbalance is coming downwards. Now let us write down the equations, okay, to solve this. So towards it, let me call this mass as m and this mass as small m, like this we call, because it appears to be smaller over here. Okay, so towards it, what do we do? Now let us write down. So therefore, when this is going upwards, I will consider tension to be positive and mg to be opposite to it. So I can now write T minus mg is equal to mu, equation number 1. And for this one, see, this is coming downwards. So this direction is positive, the other direction should be negative. So therefore, mg is positive minus the tension is negative, minus T should be equal to ma. This is your equation number 2. Now what should I do? I will add up these two. When I add these two, I'll get T minus mg plus mg minus T should be equal to m plus capital M multiplied by a. Okay. So therefore, this minus T and this plus T goes away. So I have m minus m into g. Write it down. I'll write it down here as small m minus capital M multiplied by g is equal to small m plus capital M multiplied by a. Or your acceleration a is equal to m minus capital M divided by m plus capital M multiplied by g. Now what is the case? Now we just need to substitute the values over here. Let us see what are the values over here. What is small m? The counterbalance. Counterbalance is 640. So 640 minus, what is this capital M? Capital M is the mass of the lift plus passenger. Mass of the passenger car is 520. Mass of the passenger is 80. 520 plus 80 gives rise to 600. So it should be 600. I'll do the same thing here. 640 plus 600. Multiply this by G. I'll take 10 over here. Okay, let us see later on the closest answer. So 640 minus 600 should be 40 divided by 640 plus 600 should be 1240. Double zero goes away here. 4 ones are 4, 3 ones are multiplied by 10, which should be equal to what? 10 by 31. Okay. So if I make this 30 over here, just I need to solve this in 1 minute. Though we have crossed beyond this also. Okay, I think I'll start the timer. So it should be 1 by 3. 1 by 3 is closer to 0.33. Okay, let us see which answer is closer to it. 0.33 I don't have. I have 0.32. You have 0.032. You have. B is the right answer. Okay.